Most APIs start synchronous. The client sends a request and simply waits. All processing happens inside the request itself. When the work is fast, this feels simple, but when the work slows down, the client is blocked. What happens when we have 10 concurrent callers of our API? 100, 1,000, 10,000, 100,000, or even 1,000,000 concurrent callers. This is the breaking point for synchronous APIs. More concurrent API calls means more waiting. More waiting means slower response times from your client. Up to a point, the system looks healthy. Then you hit an inflection point at some point, and the performance falls off a cliff with cascading wait times, failures, and timeouts. Asynchronous APIs help us solve the scaling problem. The API responds immediately without waiting for the work to finish. The client receives a ticket, not a blocked connection. The client then uses the ticket to check when the work is complete. The work runs independently in the background. This is what asynchronous APIs buy you. Fast acknowledgement even at scale. The real work takes as long as it needs. The key point is the API and the work scale independently. This means that you can have independent scaling strategies. You can use different technologies and techniques on each part of your API. This pattern maps directly to cloud-native primitives. The cloud providers make implementing this pattern easy. A message bus separates ingestion from processing. Serverless workers scale the work and API independently. A document database tracks state and results. The end result is no block clients, and requests are buffered instead of just overwhelming compute and falling off that cliff. To demonstrate this pattern, we've built a fully asynchronous API example. This example implements an SSH key generation service using cloud-native primitives on AWS, Azure, and Google Cloud. The flow is intentionally simple. A client posts a request. An API returns a UID as a ticket. Serverless workers generate SSH keys in the background, and then the client fetches the results later by ticket. On AWS, this solution combines SQS, Lambda, and DynamoDB. On Azure, this solution combines Service Bus, Azure Function, and Cosmos DB. On Google Cloud, this solution combines PubSub, Cloud Functions, and Firestore.